Now I have taught you from until the continuity equation, which is the conservation of mass in open channel flow, the energy equation, which is the conservation of energy, and now I will define a practical engineering phenomena called hydraulic jump. We can derive that using the conservation of momentum or Newton's second law. Now, in order to understand the hydraulic jump, we need to understand there are mainly three types of flow. If the velocity is greater than the critical velocity, or the flow depth is lesser than the critical depth, then this is called the supercritical flow. Supercritical. If the velocity is equal to the critical velocity, or the critical depth is equal to the actual flow depth, it is called critical. And if the value of the velocity is lesser than the critical value, or the critical depth is higher than the flow depth is higher than the critical depth, we call it subcritical. Now, for the critical flow, the Froude number is equal to 1. For supercritical, this is greater than 1. For subcritical, this is lesser than 1. Now, what is Froude number? Froude number, this is actually the mathematical significance, but the physical significance of Froude number is inertia by gravity force. This is one of the most important parameter analyzing open channel flow, which is the inertia by gravity force is equal to the Froude number, which is an indicator of the velocity in open channel flow. Now we can have a clear understanding of what is a subcritical flow, supercritical flow, and a critical flow. Now we can move to the analysis of hydraulic jump. Now, imagine a channel and a sluice gate. Now, imagine Now you can see how industry or in practical lab field we generate a hydraulic jump, which is there is a particular inlet, we give a certain discharge of water, and then we provide a sluice gate with a particular small outlet or opening where the water is flowing with the gravity. Now this is the supercritical flow and this is the subcritical flow. Now In here the critical depth is less than the actual flow depth, and in here the critical depth is bigger than the flow depth. Now, when the supercritical flow meets the subcritical flow, there is a energy dissipation happening. What is energy dissipation? Now, there is only velocity acting with a really less height. It will that point it will have a maximum kinetic energy due to the velocity, and at this point it will have maximum potential energy PE due to the height. So we can see a phenomena where the kinetic energy is converting into potential energy and the height increase. That phenomena is called the hydraulic jump. Now this is the length of the hydraulic jump. If we consider two sections, this is 1, this is 2. So that becomes if this is D2, this is D1, that becomes the depth of the flow after the hydraulic jump. Now, in order to define the hydraulic jump mathematically, we need to understand that what Newton said, that the change of the momentum on that particular section is equal to the net force acting. Now, what is the net force here? Now, for the section 1, we can have the shear force here is half of rho g. For the section 1, this is d1 square. Now, if you ask me how this thing comes, now the d, there is a term z which is d1 by 2, which is the centroid, then this depth we take as d1 by 2 from the center of the depth of the centroid of the area from that section is called the z, with the value is d1 by 2. So we can have the shear force on this direction as this is half of rho gd, this is our pressure, and if we multiply it by the area d1 by 2 into b, where the b equal to 1 as we are analyzing it with unit weight, so we can have the force rho gd 1 square for the section 1. For the section 2, the force will be half of rho g d2 square. Now the net force acting on that section will be rho g, if you get common, half rho g, then we can have the value d2 square minus d1 square. Now this is the net force acting between this section 1 and 2. Now the momentum acting, the change of the momentum at this section is nothing but the mv, this is the momentum. So the change of momentum with respect to time is equal to the net force acting on this direction. So we can have the value of the m is rho into the discharge per unit weight into the weight and the velocity. V1 minus V2. So that the change of the direction. So we can have the change of in d by t. Now if we have the number of mass per second, then this value becomes rho q into V1 minus V2. Now, according to Newton, these two values are mathematically same, so we can put rho g by 2 d2 square minus d1 square equal to rho q v1 minus v2. Then we can have, if we want to differentiate this part, this thing, the v value of the v will be, v1 will be nothing but q by d1, the v2 will be q by d2 for unit width rectangular channel. So the value is g by 2 d2 square minus d1 square. Then we have q square 1 by d1 minus 1 by d2. We can get this thing here. Go back, come back here. Then you can write as g by 2 d2 plus d1 d2 minus d1, and here you can write q square by d1 d2 and then d2 minus d1. If we derive this further, then we can have now this is the quadratic equation we get for the values of d2. Now according to the Sridhar-Acharya equation, we can compute that d2 have two values, which is minus d1 plus minus d1 square plus d1 square minus 4 into a into c. What is the value of c? Q square 2q square by gd1. This is the value of our c minus 2q square by gd1. Then put 2q square by g d1 and the whole thing divided by 2. 2 into 1. Now if we consider, now we can have two certain loop, one with the minus value and one with the plus value. Now for this minus value we can't have the negative depth, so we only consider the positive value. Then we can have the depth d2 after the hydraulic jump is nothing but, you can take the plus value minus d1 plus d1 square into plus 8 q square g d1 by. Now this is the value of the depth of the hydraulic jump after the depth of the flow after the hydraulic jump d2. And then we will define the value of the loss of energy due to the hydraulic jump, and how to compute this as respect to Froude number, we will also do that. Now if they ask what is the loss of the energy due to the hydraulic jump, then we can definitely write that the del E is equal to energy of that section, the first section, and minus the energy of this section, which is, we can have the specific energy value, so we can write y1 plus q square 2g y1 square for a constant discharge minus y2 plus q square 2g y2 square. This is simply the energy loss due to the hydraulic jump. So if we analyze this further, it will have an equation of HL. I am not doing the certain derivation here. Here I will provide certain PDF notes in the end of the section of the YouTube video, so we can see the calculation. So the ultimate value of the head loss will be y2 minus y1 by 4 into y1 y2. This is our head loss or energy loss in the hydraulic jump. Now we can also compute the D2, which was our minus D1 plus D1 square plus 8q square GD1 by 2. Now our Freud number value is, I told you, F equal to V by root over GD. So if we replace the GD here and V with this Q, and V equal to Q by Y or D, and the D is, and the GD will be V by V square by F, then we can write this thing, write the depth of the flow after the hydraulic jump in terms of the Freud number, which is D by 2, 1 plus 8 F E1 square minus 1. This is the depth of the hydraulic jump in terms of the Freud number. this is our energy loss. These two things are the most important thing while calculating the energy or the hydraulic jump problems. Now I will do one last mathematical example, and by this thing I will end the lecture of our open channel hydraulic course. Now, the mathematical problem says a sluice gate discharge water into a horizontal rectangular channel with a velocity of 6 meter per second. The depth of the flow d1 equal to 0.4 meter. The width of the channel B is 8 meter, and then they ask determine whether the hydraulic jump will occur, and if so find its height and the loss of energy per unit weight, and then determine the power lost in hydraulic jump. Now the first question is, will the hydraulic jump occur? Now I told you, if this YC is greater than Y, when the subcritical flow meets with the supercritical flow, that means when the Froude number of the upstream side is greater than 1, then the hydraulic jump will form, while it will interact with the subcritical flow with the Froude number less than 1, then hydraulic jump will happen. Now let's see our unit with discharge. Q is Q by B, which is 2.4 meters square by S. Then our Froude number is V1 by root over G D1. We can put the value 6, 9.81 into 0.4, which is 3.029. Now this is certainly bigger than 1, so we can say that the hydraulic jump will happen. Now they say, what is the depth of the hydraulic jump? Up D2 we can have the value minus D1 plus D1 square plus 8 Q square G D1 by 2. We can have the D1 0.4, we can have the value of Q. If we put that, the depth of the flow after the hydraulic jump will be 1.125 meter. Now they ask, what is the loss of energy? Now the loss of energy, HL equal to Y2 minus Y1 whole cube 4 Y1 Y2. This is also the energy loss per unit weight of water. This will be also measured by the unit meter. So the value, we can have the D2 and the D1, then put 1.125 minus 0.4 cube into 4 into 0.4 into 1.125, then we can have the value of 0.5835. Say the answer will be in meter. So we can have the energy loss or head loss of the channel per unit weight of the fluid. Now the last question is, they ask the power loss. The power loss law is rho G into Q into the head loss. This is the power loss. Now the value is, we can have the Q is, which is given by, we can validated by this V and B, V into B, which will be the Q into HL. We know all the value, it will be 19.2. So equate this in with the rho G, we can have the value of the power loss, which is, now the power loss is measured by kilowatt, so there will be a 1000 divided by this thing, so we can have the value of 109.9 kilowatt. This is the power loss due to the hydraulic jump, this is the energy loss of the hydraulic jump, and this is the flow depth after the hydraulic jump. So student, for now this is the course of open channel flow. I will go to certain extent according to your syllabus, but for now thank you so much.